interconnect some of their branches so that you can actually multiply the effects, and it makes it much more efficient. Now, this whole long definition of things essentially boils down to this concept right here. That's what it boils down to. You can have one nerve which comes out, so let's say C6, and nerve C6, the branching of the C6 nerve, will then give you many branches. And those many branches can go to multiple targets. So C6 can innervate your biceps muscle. It can also innervate your triceps muscle. That's more than one target. Now, those are pretty big muscles, right? Especially like triceps, big muscle. So in fact, to coordinate things, it also makes sense that what you have is not just C6, which is going to your triceps muscle, but you will have elements of C6 and C7 and C8. You'll have elements of all of those combining together in order to go to that one large muscle. So that's the concept of many to one. Many segments coming together to then form one, what's called terminal nerve, that then goes to the target structure. So these are the plexuses, okay? So essentially, right, we talked about the word matrix, right? Matrix is really just like a network of things. Reticular just means it's a network of things. That's what plexus means. The word plexus just means net. So it's the same thing, it's like a net. Things are coming together, right? So when we look at the plexuses, we have to understand that no matter what, no matter whether, right, it's a super complicated looking network of fibers, of neural fibers, or even if it's a relatively straightforward one, this relationship here is always true, okay? So we're going to refer to, right, divisions. Now, this is the tricky part, so I'm going to draw something for you, okay? So what's going to happen is, if I start out with my spinal cord, and I'm not going to do the sympathetic stuff right now. I'm not going to do the sympathetic ganglion because I'm just trying to make a particular point right now. And I'm only drawing half. I'm only drawing half the spine. Can you see the green? Should I be doing this in black? Here, I'll do it in black. Okay, so this is basically spinal cord. So what's this right there? Dorsal root ganglion, right? Actually, I'm going to highlight it so it's easier to see from this. All right, so that's a dorsal root ganglion. What is this right here? What is that? What? What? If the bump is a dorsal root ganglion, what's it on? Dorsal root. That's a dorsal root. What's this? That's a ventral root. So what's this? Yes, that's a spinal nerve, right? That's a spinal nerve. What is this right here? What is it? Dorsal ramus. Dorsal ramus or dorsal branch. Where does it go? To the epaxial region, your epaxial structures, right? Skin, muscles, connective tissue, right? Blood vessels, all that kind of stuff. So then what's this right here? Wait, what is it? No, what's it called? Ventral ramus, right? And it goes to hypaxial structures. When I lift up my arm right here, focus on my arm, what region does my arm belong to? Hypaxial. So in fact, you have to also pay attention to the fact that your arm, right, when I hold it out like this, which part of my arm is this? Which side of my arm is this? Look at this side. What? Anterior or ventral. Which side of my arm is this? Posterior or dorsal. So that ventral ramus, that ventral branch, will also divide and branch again. So this is the weird kind of confusing part, is that will divide again. So what you end up with is you also have a dorsal division and a ventral division for the ventral ramus of your spinal nerve. Because that is what's going into your appendages. It's the same for your arm, same for your leg. So this relationship is really important. Because if you think about it and you look at the ventral aspect of my arm right here, what kind of muscle is this right here? No, what kind? What does it do? Flexor. What about here? What are these muscles? Flexors. If you look at the dorsal part, what kind of muscle is that? What about these? And what does that say right there? Dorsal divisions serve what? Extensors. We'll talk about the meaning of the elevators later when we do more muscle stuff. And then ventral division serves what? Flexors. Does that make sense? Because isn't this the ventral part of my arm? So that's what you want to remember when we're dealing with our plexuses. Okay? So, moving on from there, we're going to start with the simple one, right? I know it looks a little bit light. It'll get colored in just a second. Lumbosacral plexus. And for the lumbosacral plexus, we're actually going to focus on, right, L2 to S2, right? Because how many segments? How many segments are we dealing with? Limb, it's a limb. How many segments? 6 segments. L2, L3, L4, L5, S1, S2. Those are your 6 segments. L2 to S2. Those are your 6 segments, right? Which is what we're starting with. So we have L2 up here, and we're going to go down to S2 up there. Yes, S3 can contribute, but we're not going to worry about that, right? This is the general pattern that we're dealing with. Now, what we're going to do with our lumbosacral plexus is we're actually going to divide it up. So we start with, again, right, we're going from L2 all the way down to S2, right? So that's where we're focusing our attention. And we're going to divide this up, and we're going to divide it up into dorsal and ventral. Or if you want to think of it as posterior and anterior, that's totally fine. So what I'm going to show you is, for L2, what you should notice is there is a dorsal division. L3 has a dorsal division. L4 dorsal, another dorsal piece. L5 has dorsal. S1 has dorsal. S2 has dorsal. So you notice they're all dorsal right there. These are all dorsal divisions. And those dorsal divisions will come together and form these kind of larger structures that we see right there. So that's dorsal. Now, the parts that aren't colored in, right, that I'm going to color in now, this is the ventral division of L2, ventral of L3, ventral of L4, and then here's the other ventral part of L4. This is ventral of L5, S1, S2, and yes, I know S3 is in there too, right? So do you notice that all the dorsal parts are just going to go together and form their own particular nerve? Does that make sense? Do you see that? That's many to one. And then when you look at L4, right, we saw L4 right here. This is one splitting, so it's one too many. That's definitely what happens inside of a plexus, right? Now, this just gives you your dorsal versus ventral. But the other thing we're going to do is, how else are we going to split this up? How else? Dorsal or ventral, so what else can we do? Cranial and caudal. So that's the next thing we do, is we split it into cranial and caudal. Now, yes, I know L4 is splitting and it's a little bit weird, but if I split this into cranial and caudal, 1, 2, 3, wait, wrong color. 1, 2, 3. It splits pretty neatly. 3 above, 3 below, right? So my division is going to be right about there. There's my division. Now, if I follow that, I'm going to, yes, I have to account for the fact that L4 sends a little branch down, but essentially, look at where the division goes, just like that. See that division? So do you see how neatly we can actually now separate our lumbosacral plexus? And now what you end up with is you have a nerve that is a little bit more cranial, and it's made up of dorsal parts. A nerve that's a little bit more cranial, and it's made up of ventral parts. A nerve that is a little bit more caudal, made of dorsal. A nerve that's a little bit more caudal and made of ventral. And you essentially just have, yes, there are more nerves than this, right? But those are your four basic components, four basic nerves coming out of your lumbosacral plexus. Now, remember what we said, right? Dorsal divisions do what? They do extensors. Do anyone have any idea what femoral nerve innervates? What kind of muscles? No, muscles. What? Quads. And what are my quads doing? They're extending. Any idea what the obturator is going to do? Adductors, your groin muscles, your adductors. That is related to flexion, okay? Related to flexion. So common fibular nerve, that's also called peroneal, right? What kind of muscles get innervated by that? What? Which muscles? No. Nope, not calf. No. Yeah, your lab book is a little weird about that. I'm going to let your lab instructors ask you those questions, but when we talk about muscle stuff, man, I'm going to tell you something slightly different because it's the reality. Yeah, we will talk about that when we do your muscle stuff. Peroneal nerve does your peroneal muscles and your toe extensors. That's what it does. Makes sense because that's the more dorsal division going into it. Now, what about the tibial nerve? What does that do? Sure, it's actually the tibial part of what we call your sciatic nerve that does your hamstrings, which is flexion, right? And what else? The flexors of your toes, your calf muscles and your flexors of your toes. So the pattern is definitely holding true right here, okay? Now, if you want, right, there's actually another illustration. It's like this. This is the same thing. It's just color-coded. It just doesn't have all the lines all over it. So, femoral, obturator, peroneal, and tibial nerve. And yes, by the way, when you look at the peroneal and the tibial together, that's what creates the... Wait, hold on. Sciatic. Or you can also call it the ischiatic. Same thing, sciatic and ischiatic are the exact same thing. It's the combination of those two things which creates your sciatic nerve, right? Peroneal and tibial running together, okay? So this is your lumbosacral plexus in all of its glory, okay? So what we can see is if we understand this, you should be able to tell that there are certain segments, L2, L3, and L4, which contribute to your femoral nerve, right? L2, L3, and L4, which contribute to your obturator nerve, right? So understanding that, right, what you should be able to do then is you should be able to understand, right, that those particular segments are going to then innervate particular muscles. This is not a full list of the muscles that you will have to know later, right? But for now, for the upcoming exam, you have to know these things because these are the nerve segments, or actually what we should say is, right, segmental spinal nerves, right? But if I ask you what segment, I'm asking you L2 or L3 or L4. If I ask you segment, that's what I'm asking you for. If I ask you for what kind of fiber, then I'm asking you, is it motor or sensory? Is it visceral or is it somatic? That's what I'm asking you for. So segment, anytime you see that word segment, what should you be thinking of? Like a specific number for the spinal nerve. That's what you should be thinking of. So these are the segments which will provide motor innervation to these particular muscles. Okay? Provides motor innervation to these particular muscles. Now, yes, okay, L2 should also be included in obturator, but if we're really testing these things, we put more focus on L3 and L4 than we do on L2. So yes, I know that you could include L2 there, but we're not going to. So this is your distilled down table for you guys to look at and pay attention to, okay? So you should know this. Guarantee you should know this, okay? Because what we're going to end up doing with this is we're going to start looking at nerve deficit problems in just a second, right? Now, before we do that, we got to do the same thing with the brachial plexus. And the brachial plexus is way more complicated. It's a nightmare. It's a horrible, horrible mess. But for now, until we do muscles, which we will do later, right, next week, for now, I'm going to distill it down to five terminal nerves. Okay, we're going to focus on 5 very particular nerves. And those 5 particular nerves that we're going to look at for your brachial plexus, for you guys to kind of pay attention to and understand for now, are going to be axillary nerve, musculocutaneous, median, radial, and ulnar. Those are your 5 terminal nerves that we're going to focus on for now. Okay? Now, here it also gets a little bit tricky. It's a little bit messier for your brachial plexus, right? But what I'm going to tell you is, right, if I'm focusing on the nerves that are a little bit more extensor oriented, right, then we're really dealing with the radial and we're dealing with the axillary. Okay? If I'm talking about the ones that are a little bit more flexor oriented, right, flexors and adductors, that kind of stuff, then it's the other 3, the musculocutaneous, the median, and the ulnar. Okay, so those are the ones that are a little bit more flexor oriented. So if axillary and radial nerve are more extensor oriented, where do you think they receive their innervation from? What types of divisions? Extensors. From dorsal divisions. So what about musculocutaneous, median, and ulnar? From ventral divisions. So let's look at this. Okay. Now, for the brachial plexus, right, your book does not tend to include C4, right? But if we really wanted to, right, we should be including a little aspect of C4 up there, right? So look, that's from C4, coming like that, right? Because then that gives us 1, 2, 3, 4, 5, 6 segments, right? So it's supposed to be C4 to T1. Now, here's what you should pay attention to. We're going to ignore C4 for right now, right? And what we're going to see is there's actually, right, a portion of C5 that comes out like this, C6 that comes out, C7, C8, and T1, okay? Now, what these are doing is these are forming the beginning, right? And yes, C4 comes in, forming the beginning of your brachial plexus. So if it's the beginning and it was a tree, then what is that? Those are the roots. This is stupid to me because we already have a nervous root which is inside of your vertebral column, right? You're inside your vertebral canal, and yet we're now saying roots again. I think it's stupid and confusing, but I cannot change it. So you just have to deal with it, same I have to deal with it. Those are called the roots of the brachial plexus. In your book, they're color-coded in purple, right there, roots. Right? Now, what those roots are going to do is they're going to combine, right? So after they combine, they're going to form right here. It's like the green on green looks terrible. They're going to combine and then they're going to form this, right? Now notice in your book it's color-coded green where you combine different roots, right? So C5 and C6 come together, right? C7 stays on its own. C8 and T1, they come together. Because we're coming together, when you have roots coming together, what do you form? Trunk. What does it say right there in green? Trunks, right? So these are the trunks of the brachial plexus. Now, the trunks, what comes next? Divisions. So, yeah, your book is going to call them anterior and posterior divisions. That's the same thing as dorsal and ventral. So what we're now going to see is the dorsal divisions are going to come out like this. So here's the dorsal division. Here's a dorsal division, and here's a dorsal division, right there. Now, for the ventral divisions, this is the ventral division, this is the ventral division, and this is the ventral division. Now, what you should notice is, right, the roots actually are named for their spinal nerves, right? So C4, C5, C6, C7, C8, and T1. Those are your roots. Your trunks, right, they actually have names, and it's just based on their position. So there's a superior trunk, there's a middle trunk, and there's an inferior trunk, okay? Each one of those trunks then gives off 2 divisions, an anterior and a posterior, or ventral and dorsal. When you look at it, look at what happened with all 3 of those dorsal divisions. What did they do? they came together and they formed what? They formed a cord. Okay? So that's one single cord that you are now seeing. One single cord that you are now seeing right here. That's one cord. Okay? Now, your ventral divisions don't form one single cord, they form two cords. And those two cords, you're going to see there's one cord right here, and there's another cord right there. Those three cords that we have, the reason why they have their names is because you're referring to their location in reference to the axillary artery, which is not in this illustration. There's an artery that runs through here. It's called the axillary artery. And so, in relation to the axillary artery, this cord that you are seeing right here is lateral to the axillary artery. So it's called the lateral cord. This one that you see down here is medial to the axillary artery, so it's the medial cord. And then that one that's made of posterior divisions, where is it? Posterior divisions. So it's posterior to the axillary artery, so you end up calling it the posterior cord. That's it, that's how those are named. Now, what type of muscles should be innervated by nerves coming off of the posterior cord? Extensors. Now, do you remember I told you to focus on the radial and the ulnar? Here's the radial nerve right here. Where did it come from? What's it essentially branching off of? The posterior cord. Here's the axillary nerve. I told you to focus on that. Where is it coming from? Posterior cord. Now, when we look at, right, the lateral cord and the medial cord, they should be going to what kind of muscles? What? Flexors. And the nerves that go to flexors are nerves like the musculocutaneous nerve. Where did the musculocutaneous come from? Lateral cord. Now, the ulnar nerve, where did it come from? The medial cord. And then here's a funny one, right here. You actually get a contribution from the lateral cord and a contribution from the medial cord right here. And when they join together, what do they give you? Which nerve? Median. They give you the median nerve. Okay? Oh, and by the way, right, there's this little thing. You are not going to dissect this on your cats, right? But if for whatever reason you leave, you move on to some other program, and they make you dissect stuff again, right? And you're like, oh, okay, I've done this before. I recognize these things. I'm going to show you something. If you ever have to dissect a brachial plexus on a human being, not on a cat, you won't really see this as well on a cat or a dog or whatever. On a human being, ooh, sorry, that was the wrong color. Or the wrong, right. Human being, do you see this right here? Can you see the highlighting? What does it look like? Yeah, looks like the letter M. Nope, can you guys see it? So those flexor muscles, right? The nerves that go to them, right? The musculocutaneous, the median, and the ulnar, they form. Some people, right? Like they relate it to like what's it called? Fortune telling, palmistry and stuff, and they go, oh, it's like the magic M on your hand. I don't know if you know what I'm talking about. Anyway, it's like a little magic M. So if you're ever looking for the brachial plexus, you look for the little M, and you find that inside here, and you know which are your, right, median, ulnar, and musculocutaneous nerve, because they only come out of that little M right there, right? You might see it on the cadavers this quarter, but I don't know that your lab instructors will show you that, okay? So I'm going to show it to you right now. Okay. Same idea is you should understand and memorize. Yes, I tell you, you don't have to memorize, as much as you think you do. This you have to memorize. You got to know these because again, these are the segments or roots that are providing motor innervation to these particular kinds of muscles coming out of your brachial plexus. Okay? So yeah, you should know this because you should be able to understand whether, right, you have a motor deficit or a sensory deficit. And the only way you're going to be able to do that is if you understand what your segments are, right? So yes, theoretically, or actually realistically, I will ask you questions where I tell you this muscle can still contract, but this particular dermatome does not feel anything. Where's the problem? If I tell you that you should actually be able to use this information and go, oh, well, this, right, muscle is innervating, is receiving innervation from segments C5 and C6, and it's working just fine, but this particular dermatome can't feel anything, so that means that this segment, right, has a sensory deficit instead of a motor deficit. If you can still sense things just fine, but you can't actually move that muscle, that means you have a motor deficit. That's what you're going to use this information for. So now, here's where we're going to put that stuff together. And you're going to be able to understand, right, how to use that kind of information. So we have two different kinds of lesions that you should understand, right? So one of the kinds of lesions is a lower motor neuron lesion, right? And with a lower motor neuron lesion, right, you're going to have some very particular symptoms. One of them is atrophy of the muscle, right? So this is muscle wasting. The muscle actually wastes away and gets smaller. This is not in your book, which is why I have to tell you all this stuff. The reason why is because the neurons themselves, the motor neurons themselves, are actually releasing what are called trophic factors, and they help to keep the muscle alive and healthy, okay? If the lower motor neuron, which is going to the muscle, is dead, it's disrupted, it's damaged, you're not going to release trophic factors anymore. You don't have to remember the word trophic factors. You just have to know that lower motor lesions will produce muscle atrophy, and the muscle will get smaller and waste away, okay? Because no more trophic factors. Now, the other thing is, hypo means less. You're going to have less tone in that muscle, because the other thing that lower motor neurons are doing is they're going directly to the muscle, and they are providing a constant low-level stimulation, a low-level excitation. That means that your muscle will have not totally loose and flaccid, but it'll have a little bit of tone to it, okay? If you destroy that, no more lower motor neuron, then that means you don't have that signal going there anymore. So, less tone. The muscles will be flaccid, okay? Hyporeflexia means less reflexes. Why would you have less reflexes if you destroyed the lower motor neuron? What? You cannot send the signal to the muscle. Doesn't matter how bad you want to send the signal. If that neuron is damaged or gone, then you can't do it. So that's hyporeflexia. Now, here's the other thing. It actually tends to only affect very small groups of muscles, or maybe one single muscle, or maybe even one single part of a muscle. So you can have a lower motor neuron lesion where most of the muscle still works, but one side, if you damaged one side, it will be weaker than the other side because you've only damaged a very specific part of the innervation to it. So really, really specific effects, okay? Now, if we are dealing with I was going to give you examples, right? So the lower motor neuron lesion, really specific nerves that might be affected. So if you were to damage your peroneal nerve, we talked about your peroneal nerve actually goes to, right, the extensors here and the peroneal muscles. Those peroneal muscles are responsible for, when I lift my toes, what's that called? Dorsiflexion. So those muscles and that nerve is responsible for dorsiflexion. Now, when you're walking, right, you're actually supposed to dorsiflex when you walk. So when I take a step forward, I don't take a step like this, right? That's not how I step, okay? Normally, I don't lift my foot very much, so I go like this. But when I do that, what you may not be aware of is you have to dorsiflex your foot, because if I do not lift my toes up, then this is what will happen. And I'm going to drag my toes. So, what happens? It says so right there. What do you get if you damage your peroneal nerve? Toe drag. Foot drop, right? Your foot drops down, so you get toe drag. Now, if that's the case, right, you can accommodate to that, and the way you do it is by lifting higher. Because when your toe drops down, as long as you lift it a little bit higher, it's not going to drag anymore. So then you end up walking like this. Your toes point down, but your knees have to come up a little bit higher. What does that look like when I walk like that? What does it look like? Marching. It looks like marching. Does it look like an animal?
Horse.
Looks like horses, the way horses walk. So because of that, it's called equine gait, right? Or, right, you can also call it steppage gait, right? Now the other thing is, when you do that, I have control, but it's really hard to, like, you can try at home, it's really hard to let it just totally relax. The other problem is you lift it higher, but remember, you can't lift it up. So when your foot goes down, it goes like this. And it slaps the ground. So it's also called slapping gait, okay? Now, another example is if you have damage to your superior gluteal nerve. Your superior gluteal nerve is here on the, actually going to the muscles on the side, not to the back. Goes to the side right here, okay? So, when I walk, the other thing I have to do is I have to take my weight and I have to put it all on one side. So I gotta do like this, I gotta put it all on one side, right? Now, when I do that, and I put my weight on one side like this, right? If you really pay attention, and you should try this, go home and try it, right? Is you lift up like this and you're balancing on one leg, relax, and then put your fingers, right, not on your hip bone, right, but just a little bit to the side right here, and then do it. And what you should notice is your muscles, your gluteal muscles have to contract a little bit. The reason why they have to contract is, I'm going to put my hands on my hips so you can kind of see what's going on. The reason why they have to contract is when I'm normal human being and I do this, right? Did my hips really move? Right? I'm trying to show you where my hips are. Did they move? No, right? But that's because I'm contracting these muscles. If I don't contract them, then my hip's going to do this. It's going to drop. Right? So I go like this and my hip drops like that. What's that called? Hip drop. The problem is if I walk, right? I go like this, I can't walk normally, right? Now, do you have any idea normal human beings who definitely are going to show hip drop? Any idea? Toddlers. Yeah. So here's how you get rid of hip drop. Instead of allowing your hip to drop like this, right? What you do is you take your weight and you swing it over to the side. So instead of going like this, you go like this. Yeah? And then you can walk like this. So who walks like that? Toddlers. Do you know why? Totally normal. It's totally normal for them to walk like. I'm exaggerating. Also, they got massive heads. I'm exaggerating it, right? Why do they walk like that? What? Why? Because their muscles haven't developed yet. That's why. They're not strong enough to support them yet, right? Or if you're an adult and you have damage to the nerve, then you will see hip drop, and then you will see what's called a waddling gait. You waddle from side to side, right? Now, if we move all the way up here, right? The names, they used to call it Saturday night palsy, right? Because this is when like people would go like fall asleep and black out drunk on a park bench, and they put their arm like over the park bench like that, right? Your brachial plexus runs through here. The other way you can do it, current modern day stuff, is if you've ever had crutches, do not ever put the crutches inside your armpit. The reason why they have that little hand thing there is not for convenience so that you can move it, it's so that you rest your weight on the palms of your hands instead of in your armpit. Because if you put that crutch up in your armpit, you're going to damage your nerves. And when that happens, right, if you damage your radial nerve by putting weight on there, right, then you might actually have damage to your radial nerve, meaning your extensors can no longer work. So you go like this. So what's that called? Wrist drop, because you can't lift your wrist up anymore if your extensors don't get innervation, right? Another thing is you might not even be able to extend your arm anymore because you damaged your radial nerve, okay? So these are lower motor neuron indications, right? If you see these particular signs, especially if they're localized to one side, right, then you know that there's a motor problem. Okay, upper motor neuron lesions. When we're talking about upper motor neuron lesions, right, upper motor, why would atrophy not be like a common symptom for upper motor neuron lesions? Why? Why would atrophy not be a common symptom? Okay, yes, so exactly. The upper motor neurons are not directly synapsing on the muscles. So if you have an upper motor neuron lesion, is there anything wrong with the lower motor neuron? Okay, just we're isolating. Yes, if there's massive, problems, then you might, but we're assuming that you have not damaged your lower motor neuron. So if that's the case, you still have trophic factors. So you're not going to have immediately noticeable atrophy. Ultimately, your muscle might waste away because you can't use it as effectively, so then it'll get smaller, right? Why would you have hypertonia? Hypertonia means you have more tone than normal. The muscles are not flaccid, they're actually rigid, okay? The reason why, right, and there are specific symptoms, right, spasticity, right, and clonus. Clonus is that kind of like, tension coming out like this. The reason why is because those lower motor neurons, not only were they sending out a slight signal to contract, they were also sending out an inhibitory signal. So when you destroy the lower motor neuron, you can no longer, right, actually inhibit, and what ends up happening is you actually get like more tone and the muscle stays a little bit contracted. I know it sounds weird and opposite, but that's exactly what happens, okay? Now, why hyperreflexia then? If you have a upper motor neuron problem, right, and the lower motor neuron has not been damaged, right, then why would you have hyperreflexia? Would you still have reflexes? Which neurons are involved in your reflexes? Lower motor neurons, right? Sensory and lower motor neuron, right? Now, here's the thing, right? Oh, what did I say? What did I say was sending the inhibitory signal? Did I say lower? Oh, I'm sorry. Upper. The upper motor neurons are sending the inhibitory signal. I'm sorry. So it's like upper motor neurons are sending an inhibitory signal. So, right, that's why you have a little bit more tone, because remember, the lower motors are sending a signal to contract a little bit. That's fine. You're going to have a strong contraction signal. If the upper motors are not sending a slight inhibitory signal, then you're just going to have a lot more contraction. The same thing happens for your reflexes, is if your lower motor neurons are working fine, when the reflex occurs, instead of just having like a little reflex like that, your upper motor neurons are not inhibiting anymore, so when you do it, it goes like this. And you have a greater reflex reaction. Reflexes are more pronounced, right? Now, this is really important. It affects much larger groups of muscles. Why? Why would that be the case? Where's the problem? Upper motor, which are located where? Brain or spinal cord. What if it was all the way up in your brain? What if that's where the damage, the lesion, the disease process was occurring? Right? Is your brain, right, if you damage like a significant portion of your brain, is it really just going to affect one muscle? It's going to affect much larger regions. And that's exactly what you see with upper motor neuron deficits. Okay? Now, here's something that's really weird, and I don't have a good explanation for it. It's just something that they've noticed. The muscles that work against gravity tend to have like the most contraction to them. Okay? So, muscles working against gravity, meaning, right, if I work against gravity, like that, what am I doing when I work against gravity like that? What am I doing? I'm pointing my toes, right? So your toes will end up pointing more, right? Now, these muscles, my extensors, those are the ones that are working against gravity, holding me up like this, okay? Same thing for my arms. Which muscles, I'm working against gravity, which muscles am I using? Flexors. So here's what ends up happening is, those muscles that work against gravity contract more. So my flexors, right, are going to contract. So my arm ends up looking like this. Same thing happens with your legs. Your extensors are stuck in the extended position, and your toes end up pointing. So you end up looking like this, like that. And actually your knees kind of point in a little bit. And so, right, these are very, very, let's say, consistent signs of upper motor neuron problems. So what we're going to see is, you have what's called circumduction gait. Because if my toes are pointed and my extensors are stuck in position, and it only happens on one side, if it's on one side like this, so this leg is okay, right? So I can just, flex and do this. But this leg cannot flex, so my leg is stuck out like this. Then I'm going to end up doing that, right? But that's not comfortable, right? And it's really very frustrating. So what you do is you accommodate for it by doing this. And I'm exaggerating it like that. So what am I doing with my limb? Circumduction. That's why it's called circumduction gait, because you swing your leg out to the side like that. Okay? Now, the reasons can be all there's like super varied, but what's most important is that you know that it's something in the central nervous system. Either it's your brain or it's your spinal cord, right? So if it's bilateral, if it's happening to both sides, if it's affecting both sides, then instead of being able to do circumduction, or I can go like this, right? But remember, your knees are going to point in a little bit, so you end up like kind of crossing your feet, right? So you go like this. So your toes are pointed, and you do this. And you walk like that. So what does it look like I'm doing? Scissoring. That's why it's called scissors gait, because my feet and my legs are scissoring across each other. That's if it's affecting both sides, okay? Now, it's because, right, you have hypertonia for your muscles that are working against gravity. So you cannot flex your legs very easily, okay? Now, this could end up being, right, problems down in your kind of thoracic and lumbar region, right? Like lower thoracic, upper lumbar, because that is where you're going to get the innervation that goes down to your lumbosacral plexus. Because remember, we were talking about dragging down of those segments. Where originally, remember I pointed out L1? Where was the L1 coming off of your spinal cord? In the thoracic region. So if you have damage to the thoracic region, you're actually going to see effects on your legs of upper motor neuron deficits. Okay? So that's the idea for those. Now, we'll take a break, and then we'll talk about autonomic nervous system.